Hi friends, welcome to Unacademy. Myself Bhavani. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who want to excel in a CET exam in the year 2021 can subscribe the plus courses. There is a 12 months plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125. There are different batches available. You have a comprehensive batch, okay. Also you have a Kannada batch, and you have also a champions batch with different combinations. You can enroll your name for all these batches, but then make use of the code Bhavani Live and get the discount. Kindly make a note of it. This is a code you are going to use, which will give you the maximum discount. So kindly use Bhavani Live. And also students, remember, whenever you offer a plus course, both class 11 and class 12 topics that will be done in detail. All the topics, all the necessary tips and the tricks will be shared during these sessions. You will be given, previous year question papers solved. You will also have daily practice paper. You will have full-length mock tests with analysis. So, single subscription but unlimited access student. Therefore, see to it that you will be joining this batch and taking a maximum benefit from all these classes. Apart from that, you are also given free practice tests. Before you face the CET exam, you need a very good practice. So therefore, a lot of practice tests will be given, attempted live, and see how well you have prepared for the CET exams. Okay. Students, if you haven't watched my previous YouTube session, kindly watch them. And whenever you like my class, do not forget to like and share the videos among your friends. It becomes very essential, student, that you watch the class and you share the videos among your friends. And also see to it that you are watching all my special classes under Unacademy also, if you haven't watched, and see to it that those videos also you will be sending it to other friends. So I have been conducting a lot of mock tests earlier, and also I have been doing I've started with the concept also. So I told you I'll be explaining this month all the essential concept which is required for you to learn the organic chemistry. Okay. As such, the chapter is important. Not only as such the chapter is important, but then when you learn the entire organic chemistry chapter, knowing these concepts is a must. Okay. So today we are going to discuss one more electronic effect. I have discussed two electronic effects. One was inductive effect and the second one was electromeric effect. And also we had discussed about the tautomerism or desmotropism in the previous classes. So today we are going to discuss the third electronic effect, very important one, the resonance effect or mesomeric effect. Resonance effect or mesomeric effect. So let us try to understand what is a resonance effect or mesomeric effect. Now if I take an example of, let us take CH2 double bond CH, okay, C double bond OH. Now look at this example. You can see the double bonds are in conjugation. The double bonds are in conjugation. Now when you say resonance effect is seen in conjugated compound. Conjugation means you can see double bond, single bond, double bond, single bond. That means alternate double single bond. That is conjugation. Now you can see resonance effect if the two pi bonds are in conjugation, or maybe the pi bond and the lone pair. Now we will see different cases later on. For the time being, you need to remember that resonance effect is seen in conjugated compound. There should be a conjugation. Conjugation between lone pair and pi electron. Maybe positive charge, the negative charge and the pi electron, or maybe the conjugation between two pi electrons. Okay, so students, we will see now carefully. Oxygen is electronegative, so this pi electron will be shifted. So this pi electron will be shifted like this. Okay, so the pi electrons are completely shifted, student, completely transferred from one shell to the other shell. So this is how you show resonance. So CH2 single bond, that means this has a positive charge. You have CH double bond CO minus H. So these are resonating structure. These are canonical structure. Okay, resonating structure or canonical structure. So this is resonance. Resonance means it is the movement, or I can say delocalization of pi electron, student. Pi electrons are delocalized. Delocalization of pi electron, or I can say complete transfer of pi electron. Complete transfer of pi electron from one shell to the other shell. Complete transfer of pi electron from one shell to the other shell. This is called as resonance. So we will try to understand it well. Okay. So we will see some of the important features of resonance effect. It is a delocalization of pi electron, or I can say complete transfer of pi electron from one shell to the other. Now it is existing within the molecule. It is not due to attacking agent. That means it's a permanent effect. Okay, and we have moved the electrons there, not the atoms. So during resonance, electrons should be shifted, not the atoms. And in all the resonating structure, the number of electron, unpaired electron, paired electron should be same. You cannot have different number of unpaired electron or paired electron in a resonating structure. The number of electron, whether it is unpaired or paired, it should be same in all the resonating structure. Okay, so with that we will try to understand. I hope students you have understood. If any question, kindly write it in the chat box. We will continue now. We will try to understand this effect in detail. Now, when do you see a resonance effect? One of the possibility I have told you, when the two pi bonds are in conjugation. If the two pi bonds are in conjugation, then the resonance is possible. Already we had shown this resonance. I have done this one, so I am going to directly write it. Okay. This is the first one where two pi bonds are in conjugation. You see one more, double bond, single bond, double bond. That means two pi bonds are in conjugation. So it can be a resonance, movement of pi electron can be like this. Or student, it can be like this also. There is one more possibility here. This pi electron moves here, this pi electron move here. So let me show this one. This is moving. That means this carbon has a positive charge. You have a single electron. You have two bonds here. There is a single bond and you have CH2 minus. Or you can have one more possibility where you have CH2 minus and you have, I am showing this one, this moment. You have single bond CH, you have double bond CH, and you have CH2 plus. So students, it is very clear. that here the two pi bonds are in conjugation with each other. So whenever there are two pi bonds are in conjugation, we will see resonance effect. This is also known as R effect, or you can call it as mesomeric effect or M effect. So R effect, M effect, both are same. Okay. Let us see condition number 2. And condition number 2 is, you can see now, the lone pair or the negative charge and the pi bond are in conjugation. The lone pair and the pi bond are in conjugation. Then also you will see the resonance effect, or the negative charge and the pi bond are in conjugation. Now also you see a resonance effect. So how or what happens now? The lone pair is going to move like this. This pi electron will be shifted. First of all, you see lone pair, then you have a single bond, and then you have a double bond. That means there is a conjugation between lone pair and pi bond. So lone pair, it's not directly double bond here. Lone pair, single bond and a pi bond. That means lone pair and pi bond are in conjugation. So you will have oxygen having a plus charge, double bond here. This becomes CH2 minus. So this is also resonance effect, student. Kindly remember, this is also resonance effect. Now look here, you have a negative charge, then single bond and then pi bond. So negative charge and the pi bond are in conjugation. So students, you can see the charge will move like this, and this is going to move. So you have CH2 minus, single bond, you have double bond CH2. Okay. So resonance is not just seen when the two pi bonds are in conjugation. Most of us think like that. No. It can be for a lone pair and a pi bond conjugation, or maybe negative charge and the pi bond are in conjugation. Okay. This is case number 2. So let us see the third possibility. Now, if a positive charge, you can see a positive charge is in conjugation with, the positive charge is in conjugation with pi bond. Look here, positive charge, single bond and then pi bond. So positive charge and the pi bond are in conjugation. So how does it work now? What kind of a resonance, how do you see a resonance here? So positive charge is not going to move. You know that you have to shift the electron. That means this pi electron will be shifted. I hope you are getting it. So you are getting a single bond. This carbon will have a positive charge, and this is double bond CH2. So this is also a case of resonance effect. So pi bond are in conjugation with a positive charge. Okay. Alright, we will see the next case. The pi bond now and the free electron are in conjugation. Free electron. Suppose if you think you have a free electron here and the pi bond. See, free electron, single bond and a pi bond. That means pi bond and the free electron are in conjugation. Now let us try to understand how do they show resonance. You can see from this one electron, from this a pi electron, one of the pi electron will be shifted here, and one more pi electron will be shifted here. So you are going to get CH2, a free electron, single bond, okay, single bond. You have CH and you have double bond CH2. So resonance is possible. One more possibility where you can see a resonance. So pi bond and free electron are in conjugation. Pi bond and positive charge are in conjugation. Pi bond and lone pair are in conjugation. Pi bond and negative charge are in conjugation. Okay, we will see the next one. Now, if there is no pi bond as such, the lone pair and the positive charge is in conjugation, or the negative charge and the positive charge are in conjugation. So students, here you can have shift this bond, you will get this one. So this is negative charge and the positive charge, they are in conjugation. So this is also resonance effect. Here also you will see shift of this electron, so you have double bond and plus. So this is also a resonance. So these are the various possibilities where you see a resonance structure. Okay. So resonance is possible if there are two pi bonds are in conjugation. See the conditions. One is two pi bonds. If they are in conjugation, you can see resonance. Or one is pi bond and the other is lone pair, if they are in conjugation, or pi bond and negative charge, if they are in conjugation, pi bond and the positive charge, if they are in conjugation, pi bond and the free electron, if they are in conjugation. So pi bond and the positive charge, if they are in conjugation. Okay. So this is one case. This is another case. This is another case. This is one more case. This is one more case. Apart from that, I told you the lone pair and the positive charge and the negative charge and the positive charge, if they are in conjugation, you will see the resonance effect. Now we will see how we see a resonance effect in aromatic system. You see, in aromatic system, usually we write a resonance structure. I will give you all the 4 types of examples so that whenever you want to write the resonance, you have the clear understanding. So I am going to write 4 cases here where lone pair and the pi bond are in conjugation. Negative charge and the pi bond are in conjugation. Positive charge and the pi bond are in conjugation. Pi bond and the pi bond are in conjugation. So I am going to take all the 4 cases and we are going to write now the resonance structure. Okay. See, once we write a resonance structure, then student, it is same for other compound. Similarly, you have to write. Okay, the pattern of writing remains the same. So let me begin with the first one. So I am going to write now the resonance structure for the group attached which contain lone pair of electron. So the first case where the group attached to the benzene ring has a lone pair of electron. Okay. You know that lone pair, single bond, pi bond. So there is a conjugation. So you have to write the resonance structure. When there is a lone pair and the pi electron, you have to shift the lone pair, isn't it? So lone pair is shifted. So the pi electron will be shifted like this. So you will have the first resonance structure. Okay, so look here, the resonance structure now. You have a bond and you have a bond here. This is a charge. You have double bond OH plus. So O will have a positive charge. Correct? Now, the charge will become a bond. So, and the bond is going to become a charge. So you are going to shift the electron now. So you have the next resonance structure, that is a charge here. You can see two bonds here and double bond OH plus. Once again charge bond and the bond is becoming charge. So the next resonance structure will be, so we will write, you have a bond here, here there is a charge now, you have OH plus. Okay, this charge will be bond, the bond is going to shift. So you have the next resonance structure. Okay, you have a bond here, here, and you have here, this is OH. So this will be the resonance structure for, where, a group which is attached to the benzene ring possessing lone pair of electron. You can write for any other which has a lone pair of electron in a similar manner. Okay, now students, here these 5 structure what you see, they are called resonating structure. So you have 5 resonating structure which is also known as canonical forms. Canonical forms or 5 resonating structure. More the resonating structure, more is the stability. The electrons are well spread throughout the benzene ring. If you have more resonance structure, it means that the distribution of the electron is more, therefore stability is more. Look at the resonating structure. Wherever you see lesser resonating structure, they are less stabilized, whereas more resonating structure will be more stabilization. Resonance leads into stabilization. That is because the electron which is on the oxygen now effectively distributed throughout the benzene ring. Therefore, resonance lead into stabilization. Okay. One more important point to be noted, if you have a group which is attached here, is look here now, because later on when I explain you should be remembering. Okay, when you have a group attached contains lone pair, remember the negative charge is present at ortho and para position. 1 and 2 positions are, this is 1, this is 2, ortho. 1 and 4 position is para. Once again this is ortho. So whenever the group attached has a lone pair of electron, the ortho and para positions are possessing negative charge. In other words, they are more electron rich compared to the meta position. In these resonating structure, the ortho and para position is more electron rich compared to the meta position. So I hope I am making it clear. So this is the first one. Now we will go to the second one, the second resonating structure. Now here we are going to take now benzene ring and you have CH2 minus. Okay. Now if you can see here, the negative charge, single bond, pi electron. That means the negative charge and the pi bond are in conjugation. So lone pair, negative charge, they will, they need to move. So this will be moved. Okay. Moreover, this is slight electron withdrawing also, student. So you see here, this electron is shifted. Okay. So if you can see carefully here, students, remember in this case, this group has given electron to the resonance. this group has donated electron to the resonance. Okay. Alright. So you can see the resonating structure now. Alright. So you have here the charge, you have double bond, and you have CH2. Now you know charge is becoming bond, bond becomes charge. So there is an effective delocalization. Electrons are delocalized. Okay. So there is a shift of electron. So this is resonance because the electrons have been shifted and not the atoms. And if you see all the resonating structure, the number of unpaired electron, paired electron should be same, isn't it? So like this we can write the resonating structure, isn't it? So this becomes bond. This is again going to become a charge. So you have the next resonance structure. So you have like this. So students here, so once again this is also showing 5 resonating structure. Okay. So very clear, whenever the negative charge and the pi electrons are in conjugation, you need to write resonating structure. The resonance is possible. Okay. So students, those who are listening, those who have joined, do you have any doubts? Is there any doubt, student? Okay. So it's very clear. Suppose if I have a group like this, I have substituent A, B, C, D. Now position A and B are ortho. Position AC, if the substituents are in position A and C, then it is a meta. If the substituents are present in A and D, then it is a para. Okay, this you should be knowing. Okay, so it's very clear now. Okay. So it's very clear, student, that in case of this kind of resonating structure, you will see that the ortho and the para position is more electron rich compared to the meta position. We all know that aromatic rings, they have electrons. The pi electron cloud is there, isn't it? So what happens is, since there is a pi electron cloud, okay, yes, Pavitra, it is a live session going on. So in case if you have some doubt, you can ask. All right. So student, in case if you have an aromatic system, look here now, if you have an aromatic system like this, the pi electron clouds are present. Therefore, an electrophile can easily come and attack, isn't it? Now the question is, where do they attack? If the group attached contains lone pair of electron, then ortho and para positions are electron rich. Electrophile always attack the electron rich center. Since this group is having a lone pair, as it is distributed in the ring, it will create a negative charge in the ortho and in the para position. Whenever an electrophile comes and attacks it, the product will be ortho and para product. I hope it is clear. Therefore, OH group is called as ortho-para directing group because they will direct the incoming group towards the ortho position because it is electron rich, towards the para position because it is electron rich. they are giving electrons. As a result, electron density on the benzene ring increases. So electrophilic attack becomes easy because electrophiles are attacking electron-rich center, student. Therefore, electrophilic attack becomes easier, student. Therefore, these groups, these kinds of groups are called as ring activators. Ring activators, as they donate electrons to the resonance, as they are making the compound more susceptible for attack of electrophile. These groups are referred as ring activators, and they are also ortho-para directing groups. So students, my next class will be on 19th exactly at 2 o'clock. Okay, I'll be continuing with the resonance effect and its application part, because application part is very important. So we are going to discuss all those things in the next class. So do not forget to join me on 19th exactly at 2 o'clock. Okay, so if you have liked today's class, kindly press the like button and also share these videos among your friends. So do not if at all, in case if you haven't watched my previous YouTube session, kindly watch them. Okay, and whenever you have liked it, press the like button and share the videos. Okay, so let us see on 19th exactly at 2 o'clock. Till then, bye bye students and take care.